Average directional movement index trading signals occur when average directional movement index indicator is above an upper band and there is a crossover among positive and negative directional index indicators. Therefore, we have bands and double crossover type of trading signals. First, we identify stock trending if our average directional movement index is above +20. And we have a buy signal if the previous positive directional index was below the negative directional index and then the current positive directional index is above the negative directional index, and this is confirmed by the average directional movement index being above +20. On the other hand, we have a sell signal if the previous positive directional index was above the negative directional index and then the current positive directional index is below the negative directional index, and this is confirmed by the average directional movement index being above +20. Commodity channel index trading signals occur when there is a crossover among technical indicator and its upper and lower bands. Therefore, we have bands crossover type of trading signals, in which we have a buy signal if the previous commodity channel index was less than -100 and the current commodity channel index was above -100. On the other hand, we have a sell signal if the previous commodity channel index was below +100 and the current commodity channel index is above +100. Great, so let's go back into our Python PyCharm IDE so that we can study average directional movement index and commodity channel index trading signals. Excellent. So here we are back within our Python PyCharm IDE. In this lecture, we'll be working within average directional movement index and commodity channel index code files. If you have any question about their setup, please go back to section 1, Stock Technical Analysis Data lecture, where all of that is explained with greater detail. So let's begin with the average directional movement index. As they are meant to be standalone type of files, first of all, we import our packages. Next, we do our data reading, and then we calculate our corresponding technical indicators. In this case, we calculated our average directional movement index, the positive directional index, the negative directional index, all of them with a time period of 14 days, which is the one commonly used, but you can adapt it according to your needs. Also, we have the technical indicator chart. Next, we are going to calculate bands and double crossover type of trading signals. For this, we are going to create columns with previous periods data so that we avoid the backtesting bias, meaning that we're going to implement our trading signals 1 day later from when they are observed. Therefore, we are going to calculate previous periods average directional movement index, positive directional index, and negative directional index, and second previous periods positive and negative directional index. The reason we're only calculating the average directional movement index for previous period is that it's only used for confirmation. And then, how do we calculate it? Within our original data frame, SPY, we search for the column and we shifted either 1 position or 2 positions for that second previous period's day. Then we generate our trading signals. Buy is equals to 1, sell -1, do nothing is equal to 0. We create the column where we're going to store the corresponding trading signals. In this case is ADX SIG, and first it's going to be zeros, which is do nothing, but it's going to be updated. For this, we're going to create a variable with its same name, initialize at 0, and we're going to use it within our for loop. For I, R in enumerate SPY iter rows, so it's going to iterate through all the rows within our data frame, and then we're going to ask if conditional our second previous period's positive directional index was less than the second previous negative directional index, and the previous period's positive directional index is greater than the negative directional index, and this is confirmed by the previous period's average directional movement index being above +20, then we have a signal equals to 1 or a buy signal. If this is not the case, we enter a second conditional, which is a nested if or elif, in which we're going to ask if our second previous period's positive directional index was greater than the negative directional index from second previous period, and the previous period's positive directional index is less than the previous period's negative directional index, and this is confirmed by the previous period's average directional movement index being above +20, then the signal is going to be -1 or a sell signal. If none of these two conditions is met, then we have a 0, which is do nothing. In all of these 4 loops in the corresponding I row, we're going to update our original data frame SPY ilog in that corresponding row, and the 14th column, which is the one we created for the storing of our signals, we are going to substitute with the values we calculate within our for loop. Next, we're going to create our trading signals chart. For this, it's going to be fig2, AX for access equals plt.subplots, 3 of them in this case, because we're going to have our subplot with prices, then our oscillator, and finally our trading signals. They share X as true, and then as mentioned, we have the first chart, which is at position 0, and we're going to plot our close prices with their legend located at the upper left. Next, at the first position, which is that second chart in the middle, and here we're going to chart our average directional movement index, our positive directional index, negative directional index, and we're also going to add a horizontal line with AXH line at Y equals 20 to observe if the stock is trending. The line style is dash and the color is red. Again, this is a parameter commonly used, but you can modify it according to your needs. Then we locate the legend at the upper left, and then we have the third and last subplot at position 2, in which we are going to plot the corresponding trading signals with a marker equals to O or dotted marker, line style equals to blank space, so there's no lines connecting the dots. Then we add the legend at the upper left, add a superior title to this subplots, which is SPY close prices and average directional movement index ADX 14 days, and we show the corresponding chart. So let's click the right button on the mouse and scroll down into run average directional movement index. Excellent. So in our previous section, we studied the corresponding chart in which we had our prices, and below we had the corresponding average directional movement index oscillator. So we're going to close this chart and we're going to focus in the one we just created. So let's make it a full size manually because of the screencast right over here, all the way into the right, and then as well into the bottom. So we have the SPY close prices and average directional movement index, or ADX, 14 days for its calculation. The top chart is our close prices, solid blue line. Then we have at the middle our technical indicator, and then here at the bottom we have the corresponding signals, which is 1 buy, 0 do nothing, -1 sell. They share horizontal axis of dates from the beginning of 2016 to the beginning of 2017. So let's focus on some of the signals as mentioned before. So we have here the zooming part, so let's select this part in which we have 2 of them. Excellent. So something very important, we need to focus on 3 things. First of all, the positive directional index, which is the solid orange line, then the negative directional index, which is the solid green line, and the average directional movement index, which is the solid blue line. So the crossover occurs between these 2, and it needs to be confirmed by the average directional movement index being above the corresponding threshold, which is the red color dotted line. So for example here, we clearly see our corresponding average directional movement index, the positive one, which is the orange line, going from below to above the green one, which is the negative, and this is confirmed by the blue one being above 20. Therefore, we have this corresponding buy signal being implemented 1 day later. But then we observe that the orange line goes from above, which is the positive directional index, to below the green one, which is the negative directional index, and this is also confirmed by the corresponding average directional movement index being above +20, that blue line. Therefore, we have the corresponding sell signal. So if you want to focus specifically on any part of the chart, again, remember in the bottom left hand corner right here, and using the mouse you can see the precise values from the chart. Also, going back in the zoom is just scrolling back. Excellent. So let's close this chart here. We're going to also close this one and the last one as well. We'll study all of this later on. So let's continue now with the commodity channel index, again with similar mechanics as they are meant to be standalone type of files. First we import packages, then we read our corresponding data, And then we calculate our technical indicator commodity channel index. Notice we're using those 20 periods. Again, those are the ones commonly used, but you can adapt them according to your needs. Then we have the corresponding chart. And next part is we are going to calculate bands crossover type of trading signals, first by creating columns with previous periods data to avoid backtesting bias, then generating trading signals buy equals 1, sell minus 1, do nothing equals 0 with the corresponding column CCI sig, where we're going to store the signals from the variable which we are updating within the for loop. Here we're asking if our second previous period's commodity channel index was less than minus 100, and then we have the previous period's commodity channel index being above minus 100, then we have 1, which is a buy signal. If this is not the case, we enter a second if conditional, which is an elif or nested if within the original one, which is asking if our second previous period's commodity channel index was below 100, and then previous period's one was above plus 100. Then we have minus 1, which is a sell signal. If none of these two conditions is met, then we have 0, which is do nothing. We also are updating in each of the for loops and the corresponding rows our original data frame for the signals. Then we're going to do our corresponding trading signals chart. Again, 3 subplots, first close prices with their legend. And then we have our second chart at position 1, which is our commodity channel index colored in green to differentiate from those prices. And we're having 2 horizontal lines, one at 100 and the other one at minus 100, dash type and red so that we identify the thresholds. Again, these thresholds are the ones commonly used for this indicator, but you can also modify them according to your needs. Then we're going to plot the third of the charts, which is our corresponding trading signals with a marker O or dotted marker with a line style, which is blank. And in this case, we are going to color it as orange so that it's differentiated from the rest of the charts with its legend located at the upper left. The superior title for this subplot says SPY close prices and commodity channel index CCI for 20 days, and that constant term in its calculation, which we studied in our previous section of 0.015, and we show the chart. So let's click the right button on the mouse and scroll down into Run Commodity Channel Index. So the first of the charts is the one we studied in our previous section related to those close prices and the corresponding oscillator below, which was the commodity channel index colored in green. So we're going to close this chart and we're going to focus on the one we just created. Again, as full size, but needs to be done manually because of the screencast. So let's do it all the way into the right, also all the way into the bottom right over here. There we are, perfect. So there we have our chart as a full screen. So the name is SPY, close prices and commodity channel index CCI for 20 days, and the corresponding constant term of 0.015. At the top we have our close prices with a blue solid line. At the middle we have our commodity channel index in green with the corresponding lower and upper thresholds. And at the bottom we have our corresponding trading signals. 1 is buy, 0 do nothing, minus 1 sell. These 3 subplots share their horizontal or dates axis from the beginning of 2016 to the beginning of 2017. So let's focus on some part of the chart so that we can study the corresponding trading signals. Let's say, for example, here. There we are, so that we have both of them. So as mentioned before, whenever we had a point where our corresponding commodity channel index went from below to above minus 100, which was that corresponding lower threshold, then we had a buy signal being implemented one day after. On the other hand, whenever we observe the commodity channel index going from below to above plus 100, which is the upper threshold here, then we had a sell signal such as this one. Again, if you focus on the bottom left hand corner here and use your mouse cursor, you can see the precise value of this chart. Excellent. So let's close this chart here, also this one and the last one. So now that we've finished with the average directional movement index and commodity channel index, we are going to continue with our single indicator and leading indicators based trading signals. In this case, we'll be studying our moving averages convergence, divergence or MACD together with our rate of change, and those will be our following objectives.